and half angle. When we look at this page, it says use the sum and difference identities to solve the following. Make sure to simplify. Right up here, we see sine of u plus v, right? Theta plus theta. Now, we know that in here, theta plus theta is 2 theta. So sine 2 theta. We know that if u is theta and v is theta, we could expand this and say sine of u times cos of v plus cos of u times sine of v. And if u and v are both theta in this case, we would have sine of theta times cos of theta plus cos of theta times sine of theta. On the left and the right, we see that both terms have cosine and sine, right? So we have one sine cos plus another cosine, or you could write that as sine cos, same thing, right? Means we have 2 sine theta cos theta. Or you could write that as 2 cos theta sine theta, right? Product, order doesn't matter. It's like saying 2 times x times y, or that's the same as 2 times y times x. Like saying 2 times 3 times 4, or 2 times 4 times 3. You can shuffle up the order. If we look at cos of theta plus theta, if we know u is theta and v is theta, and let's use that formula, we know cos of u plus v is going to be cos of u times cos of v minus sine of u times sine of v. And then from there we can replace the u's and v's with thetas. So we'll have cos theta times cos of theta minus sine theta times sine of theta. Cos times cos is cos squared, so we have cos squared theta minus sine times sine is sine squared theta. And now let's look at tan. So for tan, if we have tan of u plus v, we would get tan of u plus tan of v all over 1 minus u times tan of v. Then we can replace u's and v's with thetas. So we'll have tan of theta plus tan of theta all over 1 minus tan theta times tan theta. So we'll have on top 1 tan theta plus another tan theta is 2 tan thetas in the numerator. In the denominator, we have 1 minus tan times tan is tan squared theta.